Hello everyone and welcome. This is Science Visualized. Today we're looking at substitution and elimination reaction mechanisms. For elimination we're looking at E1 and E2, and for substitution we're looking at SN1 and SN2. It is possible for all these four mechanisms to be in competition or to be occurring at the same time, depending on the reaction conditions. The substrate that we're using is an alkyl halide, where the alkyl group is here, and then the halogen in this case is bromine. So the alkyl halide can react with nucleophiles, where the nucleophile will actually attack the carbon with the halogen, so you end up substituting or replacing that leaving group. So that halogen leaves. And the result is that now you have the nucleophile occupying exactly the same position that the leaving group had. If that happens, that's called a retention product because it's retaining the same configuration. The nucleophile position is exactly the same as the leaving group position. You could also have the nucleophile occupying the position opposite the leaving group. So we see the nucleophile is coming out while the leaving group was going in. So in this case, you get what's called an inversion product because the position of the leaving group is inverse, it's opposite the nucleophile position. In SN1 reactions, you end up with both of these products. So both inversion and retention product in SN1 reaction. However, SN2 only proceeds through inversion. So only inversion for SN2. That means the nucleophile position is inverse or opposite the position of the leaving group. On the other hand, you could have the nucleophile actually react as a base. So that means it has a lone pair of electrons or a minus charge. Then that minus charge will attack the proton and pull out a proton from the alkyl halide, and then at the same time the electrons that were used for bonding will flow to form a double bond, and then you end up losing the leaving group, in this case a bromine. And as a result, you end up with a double bond in this position. So you get this as the product with a double bond there. So after you lose the leaving group, you end up only with the hydrogen on that carbon. So that gives an alkene product. This reaction can proceed via two mechanisms, either E1 elimination or E2. E1 requires that this H should be opposite. So you need what's called a trans relationship. So anti, which equals to trans. So that means the relationship between the leaving group, the Br, and the hydrogen should be anti. So that means you have a 180-degree difference. So if one is going up, then the other one is going down. So that relationship gives you a trans relationship. So the Br and the hydrogen. So that's the only condition for E2. If that condition is not satisfied, then the reaction will only proceed through E1 elimination. Stay on the lookout for the next video where I will discuss more about the mechanism and the reaction conditions that will decide or direct the reaction go through either of these four possible mechanisms. Thank you. If you enjoyed this presentation, please subscribe.